Hello everyone, my name is Rohit Singhal and we were discussing about the hydrocarbons. In the previous class, I have discussed about some few chemical properties of the saturated hydrocarbons, that is alkanes. In this class, we are going to continue from the previous class only. So, now let us discuss the next chemical properties. Till now, the chemical properties we have studied. The first one we have studied was halogenation reaction. Then we studied the combustion reaction. And the next property, moving on to the next property, that is oxidation reaction. Okay. Normally alkanes do not give so easily the oxidation reaction. However, under high pressure and in presence of a suitable catalyst, that under the high pressure and in presence of a suitable catalyst, alkanes can also undergo the oxidation reaction. For example, reacting methane in presence of oxygen using copper as the catalyst and using high temperature and pressure conditions, it is 573 Kelvin, 100 atmosphere pressure. This methane molecule can be converted into the methanol. Similarly, if I use some different reagent, then the product can be varied. For example, if I use molybdenum catalysis and I heat it, it can be converted into methanol. Similarly, if I say I take higher alkane molecule, reacting it with some now different catalysts, this is manganese acetate and this will form the acetic acid. Balancing it with give 3 2. This is called as acetic acid. So, these are the different oxidation reactions where we can means by using high pressure or conditions, using a suitable catalyst, we can oxidize these alkane molecules into the further methanol or methanoic acid, depending upon which catalyst we are using. Okay. Now, the catalyst which catalyst you are using, that is the main point of focus. Normally what happens is the tertiary, if you see tertiary alkanes do not undergo oxidation, right. The tertiary alkanes do not undergo oxidation. However, they also can be synthesized, they also can be oxidized, though under very specific conditions, or we can say some suitable reagents only. This is KMnO4 and we can oxidize this CH, this tertiary alkane, that is 2-methyl propane. Remember, I have told you that tertiary alkane means the carbon that is attached to 3 carbons. So, tertiary alkane, the structure is like this: CH3, CH3, CH3 and H. This carbon is attached to the 3 carbons and now it forms 2-methyl propane 2-ol. I have told you the how to do the nomenclature. So, this will form a tertiary alcohol. So, using some suitable catalyst or reagents only, tertiary alkanes can be oxidized. Normally, they do not undergo the oxidation. Okay. The next property that we can study is isomerization. Reaction. What normally happens is normal alkanes, that is I am saying normal propane, normal butane, that means no branching, no branching, and in the presence of anhydrous AlCl3, in presence of anhydrous AlCl3 and HCl, they can be converted into the isomers product, isomers of analkanes, or we can say branched isomers of alkane. Okay. So, what actually happens is we can form the branched isomers of alkanes. For example, if I say, let us take an example, CH3, let us take an example of hexane molecule. This is a normal hexane, and treating this in presence of anhydrous AlCl3 and using HCl, we can form a different kind of isomers of hexane. That is, there can be multiple the isomers of an hexane possible. We have studied the isomers. Okay, this is example 2-methyl pentane. The other can be let us say 2-methyl pentane, other can be 3-methyl pentane. This is 3-methyl pentane. That means simple one thing is ki the normal alkanes on reaction with anhydrous AlCl3 and in presence of HCl can be converted into the branched isomers of alkanes. Okay, the branching can be introduced, and this will happen ki if I am taking an example of an hexane, it can be converted to 2-methyl pentane or 3-methyl pentane. Do you remember what does this anhydrous mean? Anhydrous means no water. Anything that means anhydrous means it do not contain any kind of water molecule. So, anhydrous AlCl3 means without water, and using in presence of HCl we can form the branched isomers of alkanes. So, the next chemical property we will discuss is aromatization. If you remember, I have already discussed about the what is aromatic compounds. So, aromatic compounds are the cyclic rings having the alternative sigma pi conjugation. Remember, I have given example of benzene. Although I will discuss about more about the aromatic compounds in the later classes, but this I have told cyclic ring with pi delocalization of electrons. This pi delocalization means the alternative pi to pi sigma bonds. For now, remember this line. Okay. So, how we can produce, let us say, benzene from this normal alkanes. So, what we have to do? We have to do 6 carbons are there. That means we need 6 carbon alkane, and 6 carbon alkane we know is hexane. In short form, we can write this CH2 4 times, CH3 and CH3. So, what in order to produce this benzene, we require some catalyst. The catalyst will be some oxidizing agent, let us say Cr2O3, V2O3, catalyst like this. High temperature we require around 700 Kelvin, 760 Kelvin. Pressure I required 10 to 20 atm, and this is how I can produce this benzene as a product from by the alkanes. How it goes from the halogen, these hydrogens are removed na. So, this is our example of this reaction is an example of dehydrogenation. What is dehydrogenation? Means removal of hydrogens. Here we have C6H14, here we have 6 hydrogens. So, how many hydrogens in total we have lost? We have lost 14 minus 6, 8 hydrogens, 4 H2 molecule we have released. Okay. So, this is an example of the dehydrogenation reaction in which aromatization product can be obtained by using suitable catalyst of the chromium oxide or vanadium oxide at high temperatures and a suitable pressure. So, that is how we can produce the aromatization product benzene. There is also one aromatized product known as toluene. This is toluene, TOLUENE. Let us say how we can produce this. We know that we need a 1 CH3, means one of the carbons will have contain 1 CH3, means a tertiary carbon, okay, means a tertiary carbon. So, simple what we can do, let us suppose we have taken this thing and this CH3 and CH3. So, one of the tertiary carbons, a methyl attached to it, and we can produce the substituent of benzene. So, the analog of benzene, that is toluene. Okay. So, in this order we can produce different aromatic products from the alkane by the dehydrogenation reaction using the suitable catalyst of oxides of vanadium or chromium. Okay. So, the next chemical property we will discuss is the reaction with steam. Let us say we react one of the methane molecule in the presence of steam. So, what happens, methane do reacts with the steam at very high temperatures of nearly 1200 Kelvin, and what it gives to produce the carbon monoxide and hydrogen gas. And this occurs in the presence of nickel as an catalyst, and this is one of the methods why this reaction is important, because this is one of the methods used to prepare hydrogen gas in industries. So, methane, the alkanes, especially methane, do reacts with the steam at higher temperatures in presence of nickel as an catalyst, and gives us the carbon monoxide and hydrogen as the byproduct. Why this reaction is so important? Because this is a reaction widely used in industries to produce the hydrogen gas. Okay. The last but not least, the reaction we will discuss is the pyrolysis reaction. Okay. Now, what do we mean by the pyrolysis reaction? Pyro means heat. Pyro means heat. So, what does it mean? That the reaction directly heating the alkanes at very high temperatures. So, what they will decompose into? If let us suppose if we do give very high temperatures to any of the things, it will at some temperature, at some point it will degrade or decompose into something. So, now we have to see if we react these alkanes at a very high temperatures, what they will decompose into. So, what happens is, if we will take let us suppose a higher alkanes, and at higher temperature, reacting with the high temperature, they decompose into the smaller alkanes, into the lower alkanes, or it can also form the alkenes. So, it can form a, let us suppose propane, it can form, is an alkene for example, okay, C4H8, it can also form C3H10, it can also form C6H12 alkene, hydrogen gas it can form. So, what it will happen, that the reaction pyrolysis higher alkanes, on heating can produce lower alkanes and alkenes. Okay. So, what does happen with this is what happens when we react the alkanes at very high temperatures, they will decompose themselves into the lower alkanes or into the alkenes. Okay. Why this pyrolysis is also important? Because what I am saying that let us take this example C12 H26. This is dodecane. The 12 carbon, the 12 carbon name is called dodecane, and heating it at 973 Kelvin in presence of platinum or nickel as the catalyst, it forms the lower alkanes, something like that. And this dodecane is a constituent of kerosene oil. So, do you remember the first class that I have discussed about what the kerosene oils are? Kerosene oils are the mixture of the hydrocarbons, and one of the main constituents of that kerosene oil is dodecane, and reacting it with very high temperature of 973 Kelvin, it will decompose. Means the kerosene oil can get decomposed into the smaller substituents of alkanes, that is heptane or pentane or any or another products, alkanes, there will be a lot of byproducts of the reaction. Okay. So, this is what the pyrolysis reaction is all about. So, I have discussed with this reaction I have discussed all the chemical properties which is required for you to study. So, of the saturated hydrocarbons, that is alkanes. First we have studied about the halogenation reaction, which goes through via mechanism of chain chain reaction, radical chain reaction. 3 steps are there: initiation, propagation and termination. The second I have discussed is the combustion reaction. The alkanes undergo the complete combustion to form the carbon monoxide and water molecule. If in case the complete combustion does not take place, it will form coke carbon solid, that is used in the ink printers. Third, I have discussed the oxidation reactions. Although generally alkanes do not prefer the oxidation reaction, they resist the oxidation reactions, but using the certain suitable catalyst, we can form a variety of oxidized products using the different suitable catalyst. The fourth I have discussed the reaction is isomerization reaction. The normal chain alkanes can be converted into branch alkanes using anhydrous aluminum chloride as the reagent or catalyst. The next I have discussed about the aromatization reaction, how aromatic products can be formed by the dehydrogenation reactions of the alkanes. And the last two I have discussed just now is about the reaction with steam, that is one of the reaction we use to produce hydrogen gas in the industry. That is why it is one of the most important reactions or properties of the alkanes. The next I have discussed about the pyrolysis reaction, that how the alkanes decompose at higher temperatures and what they decompose into the lower alkanes or the alkenes. For example, I have given the example of one of the main constituents of kerosene oil, dodecane, and at very high temperature and using catalyst, it decomposes into its smaller variants or substituent, smaller variants alkene and alkenes. So, in the next class we will discuss about some conformations of alkane, how they in 3D picture we can how in 3D they look like and how we can imagine in the 2D picture. So, yeah, thank you.